Hello, hello, this is Max, working on discussion 8, spring 2015, CS61A, and okay, we're working on scheme. And so this question is asking us to define map, where the first argument is a function and the second is a list. This should work like Python's map. Alright, so what does Python's map do? Well, if I give Python's map a list that looks like 1, 2, 3, 4, and I want to square each of the elements. Actually, let me just tell you what this one looks like. So the way map works is if I call map with a function like square that I've previously defined, takes a single argument that's going to square it, then I call it with the list 1, 2, 3, 4. It should make a new list, and that list should have the elements 1, 4, 9, 16. It's going to apply the function to each of the elements. Right. Just like we did in Python. It's just a reminder. All right, so how do we do this? So again, recursion. So let's think about what our base case should be. We're going to return a list. So what is the simplest thing that we could get passed in as either of these two arguments? Well, list seems like something that we could naturally get passed in simple, silly arguments, right? So let's first check to see whether or not list is null. This is going to be a pretty common check in Scheme. If we're sort of generating a list as output and taking a list as input. So if list is null, which means I'm passing in an empty list, well then I don't need to return anything, right? I don't need to apply a function because there are no elements. So all I need to do is return list, which is the empty list. All right, so I've done that. Now let's assume we're not being passed in silly elements. We're passed in a single argument function. Well, it seems like something that's sort of natural. A natural way to approach this is this right here. This result right here is exactly the same result as applying the function to the first element and then applying map to the rest of the list, right? 2, 3, 4. Because we know this map is going to return a list that looks like 4, 9, 16. If I combine this list with this list, then I'm going to get my answer. So this is how you can sort of think about the way you break down the recursion. This is just like in Python. I don't know if maybe that's a little easier to understand. Okay, so how do we create lists? We know we need to return a new list, so let's start by creating a list. We want to con something. What's our first element going to be? Well, our first element is going to be the first element of our original list, but with the function applied to it. So let's apply our function. Scheme notation, right? The function goes in the first position. And what is going to be our second argument? It's going to be car list. Okay, so this is the first element of the list that we've been passed in. We're applying the function to that first element. And then what should the rest of our list be? So the way this should actually look, right, is so the rest of our list, cons is going to create something that looks like 1, and then it should point to another set of lists. So it should point to something that looks like this. 4, 9, 16. And this, you can sort of think about each of these as a separate call to map as we sort of build something out. So we're going to cons this, and the rest of our list is going to be the rest of the list that we passed in, but with map applied to it. So let's say map, and we're using the same function, and instead of passing in list, we're going to pass in the rest of the list, because we've already processed the first element of the list, so that should be it. All right, so this is the final solution. We've checked our base case. We've checked to see whether or not something is null. The way this is going to work is if I pass in this as an initial list, 1, 2, 3, 4, and I pass in square as my function. I'm going to check to see whether or not this list is null. This list is not null, so I'm going to apply the function to them. I'm going to create a new list that has the function applied to the first element, which is just 1. Square of 1 is 1. And then I'm going to cons it with the result of applying map to the rest of the list. The way actually you can sort of think about this actually working is it's first going to process this function, because it needs to evaluate each of its operands before it can actually cons them together. So a better way to think about this is it's going to first create this function car list. So it's going to first put this here, or first evaluate this is going to be, and then it's going to recursively call map, and map is going to begin to, it's actually not going to create this list yet, but it's going to begin to do this with this second element. So it's going to say, what's the car of this list? Well, the car of this list is 2. And now I've done this. I've applied the function to the car of this list, which should actually be 4. And now I am going to recursively call map again. This is just like in Python. I'm just sort of making it more explicit. And this is going to apply the function to this element, because now I'm looking at the rest of the list. And finally, now I'm looking at this bit, 16. And then the last thing I'm going to do is I'm going to apply function to the cutter of this list here, which is null. We're going to hit our base case. We're simply going to return null. And now it's going to build. So now all of our cons are going to complete, and we're going to return up the chain. Okay, so that was a lot of stuff. So just an extra thing if this helps you visualize what's actually, how the recursion is actually happening. Recursion is super important in Scheme, and thanks for watching. Sorry this was a slightly longer video.